Welcome students to video 4, which is properties part 1. So I know how you feel about properties because it's probably about the same as I feel about teaching properties, which is kind of like this guy. But alas, we don't really have a choice. We do need to learn these. They are actually quite important in lots of different ways. So let's go ahead and let's turn that freaked out face there. Let's turn that frown upside down and make him a happy guy. See? See, look. Yay! He's excited about properties. Okay, so which properties are we going to be learning? We're going to be reviewing the associative, commutative, inverse identity, and distributive properties with this video. We're also going to look at how you can actually use them in a practical manner other than just having to memorize them. All right, let's jump in with the associative property. The associative property. You associate with your group. You associate with your group. It doesn't matter how you group or associate, addition or multiplication, the answer will still be the same. So the rule is that if I'm adding A and B, the quantity A plus B plus C is equal to taking A and switching those parentheses to the B plus C. So in that addition sentence, there's nothing different about the two sides. You're adding A, B, and C, but you can group them differently. And this will help us when we are simplifying expressions. Here's an example of the associative property with addition. Here's an example of the multiplication one, and here it is with numbers. Yes, you should be copying, and yes, you should be copying the way you can help yourself remember what each of these properties is. Your associates are your group. At a law firm, for example, a bunch of the different individuals who work for the law firm as lawyers are often called the associates. Those are like the youngest lawyers in the law firm. The associates, the partners, would be the lawyers that had been there longer and proven themselves. The associates would be kind of the newbies. All right, so the associative property is about grouping. Next one. The commutative property. To commute is to travel or to move. So the commutative property, lots of kids want to try to put an N into the commutative property and make it the commutative property, which it is not. It is the commutative property, a T there, not an N. So the commutative property tells us that it doesn't matter how you swap addition or multiplication around, the answer will still be the same. So here you have it with addition. A plus B is equal to B plus A. Multiplication, A times B is equal to B times A. So there's the numerical property, commutative property of addition, and there's the numerical commutative property of multiplication. So to say the commutative property has to do with traveling, commuting, the other way we often remember it is that C is for change, C-H-A-N-G-E, change, and the O right there is for order. Okay, so commutative properties, C for change, O for order. If you change the order of addition or multiplication, the answer will still be the same. Excellent. Next one. Before we move on to the next property, let's talk about this. Stop and think. Does the associative property hold true for subtraction and division? Well, here we have a subtraction version here. Our division version's a little bit confused, so I'm going to go ahead and put in the dots for division there. Because I believe that was supposed to be there. So we have this first one. Let's see if this is true. Is the quantity 5 minus 2 minus 3 equal to 5 minus the quantity 2 minus 3? The order is the same. 5, then 2, then 3, 5, then 2, then 3, but the grouping has been changed. So let's try it. 5 minus 2 is 3. 3 minus 3 is 0. So the left-hand side is a value of 0. 5 minus the quantity 2 minus 3. Well, 2 minus 3 is negative 1. So now I have 5 minus negative 1, which is really 5 plus 1, because that's how integer addition works, which makes that side equal to 6. And no, those are not true. So the associative property does not work for subtraction. Let's try it with division. They chose numbers that do divide evenly, at least in part of this circumstance here. So 6 divided by 3, that's 2. 2 divided by 2, that's 1. Are we going to get a 1 over here? Well, 3 divided by 2 is 1.5. 6 divided by 1.5 comes out to be 4. And 1, again, definitely not equal to 4. So the associative property doesn't work for division either. It's a bit more obvious down here with the commutative property, but we can see very clearly 5 minus 2, which is 3, is not the same thing as 2 minus 5, which is negative 3. And with the division, 6 divided by 3 is 2. That's definitely not the same thing as 3 divided by 6, which is 1/2. They are reciprocals, which is significant, but they're not the same. This means that we can see here that the properties of real numbers only work for addition and multiplication. That's true for the other two that we're going to look at, so let's go ahead and move forward now. The inverse properties. The inverse properties. What is the opposite? I didn't mean to move that. Hold that thought. Sorry about that. I had to lock the image in place. What is the opposite or inverse of addition? Well, that would be subtraction, or adding the negative. What is the opposite or inverse of multiplication? That would be division, which is the same thing as multiplying by a reciprocal. Let's look at these inverse properties. Here we have the inverse property of addition. Any value times its opposite signed value will give me 0. So 3 plus negative 3, 0. That's an excellent example of the inverse property of addition. We use this quite a bit when we're thinking about solving equations. We use this when we're doing integer addition and subtraction. We know that a positive and a negative that have the same magnitude or absolute value, magnitude being size, okay? So a positive and negative with the same size, they do cancel each other out. For multiplication, any number times its multiplicative inverse or reciprocal. A multiplicative inverse or a reciprocal is where you flip the number over. So when I have 2, for example, here in this example, we know that's a 2 over 1. If I find the reciprocal of that, that's where I flip that fraction over. And the significance of a reciprocal is that multiplying a number times its reciprocal is always equal to 1. We use reciprocals when we're dividing by fractions. In fact, we learned in probably, I think 5th grade, we learned that when you divide by a fraction, you actually never divide by a fraction. You multiply by the reciprocal of that fraction. So your inverse properties are all about opposites. The opposite of addition, the opposite of multiplication. All right, next one. Identity properties. Identity properties. What can you add to a number and get the same number back? Well, the only thing would be 0. If I add 0, it doesn't change the identity of the number I'm adding it to. What can you multiply a number by and get the same number back? Again, the only number that will do that is the number 1, because anything times 1 is itself. Again, it doesn't change its identity. So the identity property of addition is where you can say that any number plus 0 is itself, and the identity property of multiplication is any number times 1 is itself. So here's a number example, 3 plus 0 equals 3, and a number example for multiplication, 2 times 1 equals 2. So identity properties, the number's identity does not change. Last one for today. The distributive property. If something is sitting just outside a set of parentheses, you can distribute it through the parentheses with multiplication and remove those parentheses. We have been calling this, for the past couple of years, we've been calling this the double rainbow property. Double rainbow refers to this very strange YouTube video that some of you have probably seen. Please always ask parents' permission before you go searching for anything. But it's this guy freaking out because he sees a special double rainbow. And that right there, what I just drew, that's why we call it the double rainbow property. Because when we use the distributive property, it's A times C, and then A times B, and then A times the C, which gives me AB plus BC. So using a couple of examples here with numbers and then variables, that would be the same thing as 4 times the quantity 3 plus 2 is 4 times 3 plus 4 times 2. Now, yes, of course, we can keep going and multiply those and then add it together, and we get the same answer as if we just add the 3 and the 2 to begin with, which is 4 times 5, giving me 20. So we totally can see that, that's just 20. But this isn't really where the distributive property is significant. These two examples down here, this is where the distributive property becomes really significant. For this first one, 2 times the quantity x plus 3. Well, that's 2 times x plus 2 times 3. And we've learned at this point that we can't add that x and 3 together. That's not 3x right there, it's x plus 3. It's x with 3 more tacked on. We don't know what x is, so we can't actually say what the value of x plus 3 is. So 2 times the quantity x plus 3 is 2x plus 6. This one with the negative, same idea right here. And what this really is a negative 1 multiplied by 3 plus x. And that's what gives us the negative 3 minus x. So that's the distributive property. Let's take a look at where we'll actually use these and what types of problems I'm going to have to solve in order to practice using my properties. Let's practice identifying some properties. This is from the Regents Prep website. The Regents exam is a test that they have in New York State that's similar to the SOLs. So here we have some examples. We'll do the first 5. 6,325 times 1 is 6,325. Sounds to me like we multiplied and the identity of the number didn't change. The number is still the same number. So is that the identity property? Why, yes it is. The multiplicative identity property to be exact. Next one. The number 100 plus the quantity 52 plus 45 is equal to the quantity 100 plus 52 plus 45. Notice the order of the numbers on each side did not change, but the grouping did change. Grouping. Which property is that? Oh, I heard it somewhere. The associative property. Let's see if we can get it. There it is. Associative property of addition. On the next one we have 52 times the quantity 3 plus 22 is equal to 56 times the quantity 3 plus 22 is equal to 56 times 3 plus 56 times 22. That would be our double rainbow property. We're handing out that value, that number that we're multiplying. We are distributing it. Distributive property. 2 more. Here we have a number plus 0 is equal to itself. Once again, he has an identity and it did not change. He is who he is, that property, even if you add 0. So I didn't mean to zoom, additive identity property. And the last one we're going to look at on this page. Negative 47 times 1/47th, or negative 1/47th. And you get a 1. So any number times its opposite. Okay, opposite, what's a synonym for that? Inverse. And it's what operation in the problem? Multiplication. Multiplicative inverse property. Excellent. Let's take a look at doing some algebraic proofs. These are problems we call algebraic proofs. It says simplify each expression and justify each step. Let's take a look at number 20. Well, we have 8 plus the quantity 9t plus 4. Well, if I'm going to be able to simplify this expression, I'm not going to be able to add the 9t and the 4. Sorry, that's messy. Let me fix that. I'm not going to be able to add the 9t and the 4, but I could add the 8 and the 4. So what we want to do here is show exactly why mathematically we're allowed to do the steps that we're going to do in order to simplify this. So I want to go ahead and make sure the 8 and the 4 are next to each other. So I'm going to switch the order inside the parentheses and make it 4 plus 9t. That would be an example of our good old commutative property. Remember, commutative does not have an n in it. That's the commutative property of addition. So now the 8 and the 4 are next to each other, but they're not grouped together, so let's switch that grouping. 8 plus 4, in parentheses there, plus 9t. That would be the use of our associative property, again, of addition. To finish the problem, I can actually add the 8 and the 4, that's 12. And in some proofs, they'll call that the addition step, or just addition. But we could also actually call that the substitution property. And we call it the substitution property because we're replacing the 8 plus 4 with a 12. One is equal to the other, so we can replace one with the other. Okay, so I know at this point you should have a better idea of what the point of knowing our properties is, what our reasoning behind this is, and hopefully you're feeling a bit better than the guy on that first page. Maybe a little more like this. Maybe a little bit more like him? Even if not, thanks for watching. I'll see you in class.